Number 3, initially in a 4-liter container, there are 0.24 moles of A and 1.0 moles of B. At equilibrium, there are 0.6 moles of C present. Find K and other equilibrium values. Find percent A turned to product. And we're given the reaction. So the first thing I notice with this problem is that I have 2 different points in time. If I have initial and equilibrium, I need to be setting up a nice chart. Another thing that I have to do no matter what in an equilibrium problem is I need to write my equilibrium expression. Products over reactants will give me B squared times the concentration of C cubed over the concentration of A. Okay, I'm given initial values here, and I'm given an equilibrium value here, so I'm going to have to be really careful to put them in the right place. Also, thing to remember, you need to convert moles to molarity before plugging it in. I'm going to do that up here in this corner. My concentration of A will be my moles of A over my volume, giving me 0.06 molar. My concentration of B is moles of B over liters, or 0.25. For C, I'm given 0.6 moles of C, so the concentration of C is 0.6 over 4, or 0.15. Here's something you need to be careful of. That's an equilibrium value of C, so I need to put it down here. I'm not given an initial value for C, so I make the assumption that it's 0. Now knowing that this side increases, I can fill in my change row. This will increase by 3x, therefore the same side of the reaction also increases, has a coefficient of 2, so it's 2x. For A, coefficient of 1, it will decrease by x. In this problem, I can find x from this data. I know one full column, therefore I know 0 plus 3x equals 0.15, x equals 0.05. Now I take my x, I plug it back into these 2 rows to find, or these 2 columns, to find my final concentrations. 0.25 plus 2 times 0.05 gives me 0.35 molar. 0.06 minus 0.05 gives me 0.01 molar. So in terms of other equilibrium values, that is that part of the answer. The other part of the answer I need to do for A is I need to find K. So I have my equilibrium expression here. I'm going to plug in my equilibrium values. 0.35 squared times 0.15 to the 3rd power over 0.01 gives me a K value equal to 0.041. Also a portion of my answer. For B, I'm asked to find the percent A turned to product. To do percent turned to product, or anytime we're doing a percent, we're doing part over whole times 100. This is my original concentration of A is 0.06 molar, and my change of A, the amount that was actually converted, is equal to the X value, or 0.05. Multiplying that by 100, I get 83.3%, which is my answer to part B.